So in this question, we're told that a small factory makes bars of soap. And on any day, the total cost of the factory, which is in Y pounds, of making X bars of soap, is modelled to be the sum of two separate elements. So it has a fixed cost, and then a cost which is proportional to the number of bars of soap that are made that day. And in part A of this question, we're asked to write down a general equation linking y and x for this model. So effectively, we're going to have an equation which shows the total cost of the factory of how many bars of soap they make per day. So we know that we're going to have an equation which is y equals something. And we know we have two elements of this. We're going to have a fixed cost, which is something that is the same for if we make 1 bar of soap or if we make 20,000 bars of soap. And we know this is going to be a constant. So noting this down here, we'll have that a fixed cost implies a constant, and then we'll have that a proportional cost, so the cost that is proportional to the number of bars of soap that are made each day. So we have proportional cost. That is going to relate to the number of bars of soap made. So we know that we're going to have an equation y equals, and then we're going to have an x variable somewhere, plus a proportional constant and a fixed constant. So we can put in our proportional constant, and it is proportional to x, and then we add in c, which is our fixed constant. So then just labeling this here, we'll just put a little annotation in to make things slightly clearer for us. We have that c is going to be the fixed, and that k is going to be the proportional constant. In this part of the question, there was 1 mark available, and we received our 1 mark for stating the correct equation here. We're then given some further information, and we're told that the bars of soap are sold for £2 each. And we're told that on a day where 800 bars of soap are made and sold, the factory makes a profit, so a profit of £500. And on a day when 300 bars of soap are made and sold, the factory makes a loss of £80. And we're asked to use this information to show that y is equal to 0.84x plus 428. So this means we have two pieces of information which we can use to help us get to this point here. So let me just put a number I down here, and we're going to have that y, so the total cost is going to be the amount of bars we make multiplied by the cost of each one. So that's going to be 2 multiplied by 800. And then when we have 800 bars of soap, we know that there is a profit of £500. So we subtract 500, which then will give us the total cost. So then following this sum through in our calculator, we'll have 1600 minus 500, which is 1100. So this means that we now have an x coordinate and its corresponding y coordinate. So just write this like this, xy is going to be equal to 800 and then 1100. And then doing this for our second piece of information here, just doing the same thing, we have each bar of soap is sold at £2, we have 300, and we can work out the total cost by this time adding on the loss, since it's obviously a negative, so we therefore add it on. So that's 2 lots of 300 plus 80, and putting this into our calculator, this comes out as 680. So likewise, we can say that the coordinates x, y are going to be 300 and then 680 for the y coordinate. So then we remember back to our original kind of equation that we set up in part A of the question with our constants k and c. So this time, for I, we're going to have 1100 is equal to 800k plus C. And for I, so our second piece of information, we're going to have that 680 is equal to 300k plus C. So all we've done is substitute x and y into our equation from part A. And we'll just write this on the side here just so we remember what it was. It was y is equal to kx plus C. And that, recall, was from part A of the question. So then we have substituted our values into this here, and what we now have is we have two equations with both with k and a c. So we can solve these simultaneously. So we rearrange to have that c is going to be equal to 1100 minus 800k, and for our second equation we have that c is going to be equal to 680 minus 300k. And what we now do, we then equate these because we have something equal to c and something equal to c, which means that this is going to be equal to this. So we'll have 1100 minus 800k, and that is going to be equal to 680 minus 300k. And then we rearrange this and we have that 500k, so we've added 800 to both sides, and then that is going to be equal to 1100 minus 680, which is 420. So we now have this equation here, 500k is equal to 420. And what we'll then do with that is divide both sides by 500, and then putting into our calculator 420 divided by 500, we have that k is going to be equal to 0.84. And what we can then do is we take our equation for c. So we take this equation here, and then we have that c is equal to 1100 minus 800 lots of k, and we've just worked out what k is. So we substitute that in and have 0.84, and then putting that into our calculator, this comes out as 428, and that is equal to c. So then what we can do is we can go back to our original equation, y is equal to kx plus c, and we substitute our values for k and c in, and we have that y is equal to 0.84x plus 428, and this is what the question asked for, so as required. This question was worth 3 marks, and we pick our first mark up for correctly calculating both of the coordinates, so that using the x coordinates and this equations here to calculate the y coordinates. We then receive our second mark for correctly working out what k and c are, so the second mark is awarded here, and then we receive our third and final mark for coming to the correct conclusion and relating it back to the question. So now taking a look at part C of this question, we're asked with reference to the model to interpret the significance of the value 0.84 in this equation. So we recall what was the equation we're talking about. So it's the equation which we've just proven in the previous question, and just noting it down here in purple, we have that y is equal to 0.84x plus 428. So we recall that 428, that was a fixed cost. So there would be a cost of £428 if we made 0 bars of soap, or if we made 1 million bars of soap. So it's a standard cost which is fixed and it's always going to be there. And then we have that 0.84 is a cost that is proportional to the number of bars of soap that are made that day. So in practice, what does this mean? So this means that for each bar of soap extra that we make, there will be a cost of £0.84. So in other words, for every additional bar of soap we make, it will be 84 pence more expensive. So writing this down, we have that 0.84 is the cost of making each additional or extra bar of soap. In this question, there was 1 mark available and we receive it for writing down 1 correct conclusion. For part D of the question, we are told to assume that each bar of soap is sold on the day it is made. And we're asked to find the least number of bars of soap that must be made on any given day for the factory to make a profit. So we're going to start by letting N be the least number of bars required to make a profit. Then what we can say is that 2N is going to be equal to 0.84N plus 428. And then dividing both sides by 2, we'll have that N is going to be equal to 0.42N plus 214. And then we can rearrange this equation to solve for N. So subtracting 0.42N from both sides, we'll have that 0.58N is going to be equal to 214. And then now dividing both sides by 0.58, we have that N is equal to 368.965. And we're asked to find our answer to a bar of soap, and we aren't dealing with decimal bars of soap, we're dealing with full bars of soap. So we therefore round this to the nearest whole number, which is 369 bars. So there was 2 marks available in this question, and we receive our first mark for knowing to make 2N equal to our equation from the previous question. Then we receive our second mark for concluding with the correct number of bars of soap, which was 369 bars.